Hello students, I miss you guys. We're here to talk about algebra half. So we'll keep on keeping on through the Saxon Algebra Half textbook. We left off with lesson 97, so we'll be picking back up with lesson 98. The format that I'm going to be doing is I will record a video for each individual lesson, and then you can watch them all at once. You can watch them as you do the lesson. You can ignore me completely. Just kidding. I don't recommend that. But that way the files aren't huge and you can access them on YouTube, and I will post links on the Edmodo page that we are used to using, as well as homework. You will still be having quizzes and such, so be looking for those to be uploaded to Edmodo, and then you will have to take pictures of those and send them back to me for grading. But we won't have one this week, we'll have one next week, because this technically would have been the week that your midterm was due. And speaking of midterms, just so you guys know, I've only received 2 midterms. So they were due yesterday, so maybe you guys aren't checking your Edmodo, but I will give you an extension to Monday. So please, please, please get me your midterms. I believe it's March 30th. The Monday. Anyways, Monday, I need your midterms. Email, Edmodo, whatever. Please send me just a picture of the front page that I handed out in class of test 24 with the answers clearly written on it. Thank you. All right, so let's get started on lesson 98. So this is going over some geometry topics. We're going to be talking about adjacent angles, complementary, supplementary angles, and then we're going to be reviewing how to measure angles. You should have been working with a protractor for quite some time now, but we'll do a review on that. So let's dive right in. If you're on page 303 in your Algebra Half book, you can see the first thing we're going to talk about is adjacent angles. And it says we can name some angles by using the letter of the vertex. Now remember, the vertex is where 2 lines come together. So vertex or angle A, B, and C here. Okay, so we would read this as angle A. This is angle B, and this is angle C. So it looks like A and C are probably acute angles. B looks like it could be a right angle, but we're not completely sure yet. And plus, it's just Mrs. Strawn's scribbles on the board. But when we want to write these, we want to use the little symbol that looks like a angle, right? A, B, and C. So when you see that, now know that you can with confidence read this as angle A, and it's referring to angle A, and then obviously B and C. Now, when 2 or more angles have the same vertex, sometimes it's actually necessary for us to use 3 letters to name the angle, okay? Because what if I said angle A? Does that mean this angle? Does that mean this angle? Or does that mean them both? Okay, so we would have to use 3 letters. Now, hopefully you're looking in your book, and I'm not going to write them all up here on the board, but you can see this. We could say angle MAB, MAC, MAX, MAY, CAX, CAY, BAX, BAY, and then you can actually say them backwards, right? You could say YAM. Now that means the same thing as MAY, doesn't it, okay? And then likewise, YAB would be the same thing as BAY. So it doesn't matter which order they're in, as long as the vertex is the middle letter, right? Because if we said angle YCA, would that mean the same thing? No, because there's no line connecting these 2, right? So they have to go in order with the vertex in the middle. All right, now this is a congruent angle where adjacent angles. There's another illustration in your book, and I'm just going to write it under here. Sorry, where we have another angle and then an angle coming off of it like that, okay? If 2 angles have the same vertex and share the sides between, then they are adjacent angles, okay? So this is not an adjacent angle. These 2 are adjacent angles. They are next to each other, okay? So this one is labeled A, angle Y, angle, sorry, that doesn't look like y, angle x. And then we have some points B and C. And these are all rays. Okay, so these are not adjacent angles because they don't share the same vertex. These two angles would be adjacent angles because they share the same vertex, okay? So that's just a little review, how to read angles, and then the difference between adjacent angles and non-adjacent angles. And then we're going to move on to the next concept, which is complementary and supplementary angles. Now, I actually like the little trick that they give you in the book on page 305. They draw out a little diagram. Okay, so this is for complementary. I'm going to write comp. And this is for supplementary. I'm going to write sub. Okay? Now, complementary angles are angles that add together to make 90 degrees. Okay, so these are supposed to be 90-degree angles. Supplementary angles are angles that add together to make 180 degrees. Okay? So are you seeing now why, sorry, hold on. This is like real class. If you notice, I'm in our actual classroom and no one's supposed to be here, but someone's out in the parking lot and their car alarm was going off, so I just wanted to make sure it wasn't my car and something funky wasn't going on. So excuse me. All right, so this one angle, if you turn it on its side, the 90-degree angle kind of looks like a C, doesn't it? So try to remember C, complementary, 90-degree angles. Two right angles put together in this orientation kind of look like an S, don't they? And two 90-degree angles together equals 180 degrees. So supplementary angles are angles that are added together to make 180 degrees. The other way that I remember it is C comes before S in the alphabet. So C is the smaller one, S is the larger one. C is 90, complementary, S is 180, supplementary. All right? So we will get, let's look at the first example. The first example says, what are the measures of angle ABC and DEF? And so we have a straight angle, we have a 90-degree angle, and then we have this. This tells us it's 30 degrees. This tells us it's right. And then it wants to know angle ABC. Let me label these. Now these get kind of tricky, and you have to be kind of smart about it, okay? So if you know that this is a 90-degree angle, and if this is a straight line, okay? If this is 90 degrees, this angle, we'll put a 1 here. This angle 1 and angle 2 have to equal what? 90 degrees, okay? Because if this is a straight angle and this is 90 degrees, that means that the angle 1 plus angle 2 equals 90 degrees. So if this is 30, what's angle 2 going to be? If angle 1 is 30, what's angle 2? Well, if together they're 90, we take 90, we subtract 30, and we find that this is 60 degrees. Now remember, degrees is that little tiny bubble thing after the number, okay? So we know it has to be 60 degrees. Now the next portion of that example gives us another straight angle, and it gives us a line or a ray going up, and then it tells us the angle that that forms is 45 degrees, and then it labels F, E, D, and it wants to know the measure of angle D, E, F. Remember, F, E, D, and D, E, F are the same thing. Okay, so again, if this is a straight line or a straight angle equals what? 180 degrees. So if this is 45, what's this portion going to be? What's F, E, D, or D, E, F going to be? Well, we have to take 180 degrees, and we have to subtract out 45 degrees, correct? And so we borrow 5, 3. So it's going to be 135 degrees, okay? So just remember that a straight line is 180 degrees. Where do we get that from? Well, if we look at a circle and we cut it in half, right? If we start here, and go all the way around, it's 180 degrees, right? Half of a circle, 180 degrees. The measure of a straight line is 180 degrees. Okay, so just remember that they're going to give you, on these diagrams, they're going to give you all the information that you need to figure out the unknown angle. So just walk yourself through things step by step. Okay, I know this is 90. I know that means that this side together is 90. If this is 30, this is 60. I know this is 180. If this is 45, this angle has to give me a number that then will add up to 180. So find the difference between 45 and 180, and there you go. Now, the next portion of this lesson is about protractors. Now, I'm going to do my best to show you about the protractors using this video technology that we're doing. But remember that your protractor has some unique parts about it, okay? First, you can see that dot right there. That's where your vertex is going to line up with, okay? So make sure you line that dot up with your vertex. And then running right through that dot with the vertex is going to be a straight line. That's where the bottom of your angle is going to go, okay? So the base of your angle, the bottom line or ray of your angle. So you need to line it up there. Now, if your angle is opening your angle is going to open one of two directions, okay? Whatever angle, whatever direction it opens, you have to make sure that you're measuring on the right line, because if you look here, we have a 0 to 180, and then on this side, technically it starts at 0, but it gives us some space and it goes from 10 to 180, okay? Because of the way that the protractor is lined up. So you can flip it back and forth for whatever way that you're most comfortable working with it, but you have to make sure, number one, that your vertex is in that hole, that the bottom line of your angle is on that line that goes across and through that hole for the vertex, and then that you're following the right direction on the protractor. So if your angle, let's say, here's our angle, it's opening to the right. So I'm going to line up my protractor with my vertex and that bottom line. And then because I'm opening this direction, this line, whichever series of numbers or measurements that I'm going to follow has to start with 0. Okay, so I'm going to start with 0. So I'm on the inner line right now. I'm on the inner set of numbers. And I can see that this line is about 35 degrees. Now, one of the things that you can do to make sure you're on the right line, we know this is acute angle, right? This is an acute angle. So if I look at the wrong line, this is going to tell me it's 135 degrees. Is this a 135 degree angle? No, because it's not larger than a right angle, correct? So we have to make sure that we're following the right set of numbers. That's the biggest problem that we have when we're measuring angles, is just making sure that we're following the right set of lines. Now, you have a printed protractor in your book, and you're just going to be responsible for measuring the different angles, and so make sure that you're paying attention to which direction the angle is following based on the coordinates or the letters that they've named the angle that they've given you. Make sure you pay attention to those, and make sure that you use your finger to follow the numbers and stuff, okay? This was a hard lesson for us to do virtually because I'd really love to be with you in the classroom, like touching and feeling and playing with these, but hopefully you've worked with protractors enough to kind of have a basis for understanding them. And then if anyone's struggling with it, we can Zoom, we can FaceTime, we can email, text, or when all this is over, I can sit down with you and give you some one-on-one time about how to use a protractor. Please don't hesitate to reach out for help. Do your lesson. The assignment's on Edmodo. See you for lesson 99 in a minute.